In this session we are discussing voltage comparator using LM339 IC. It is quad comparator, 4 comparators in one IC. What is comparator, how it works, and how to understand this test circuit. Let's start. Assalamu alaikum wa rahmatullahi wa barakatuh. I am your host Muhammad Ashraf and I welcome you on my YouTube channel. If you are new to my channel, I will invite you to subscribe it. Press bell icon and notification for all so that you will be notified for my future uploads. Comparator. Basically, comparator is linear IC. If we see its symbol looking like an operational amplifier, there is comparator sign. Two inputs, inverting input and non-inverting input. Two power supply pins, positive VCC and ground pin. Power supply rail is common for all 4 channels. Opposite to operational amplifier, comparator has open collector output. So that we will need a pull-up resistor to take output. 2 inputs, one is with positive sign, second is with negative sign. Positive signed input is non-inverting input and negative sign means it is inverting input. I built this circuit and assembled it to save the time. We provide a reference voltage to this inverting pin. Non-inverting pin is less than this pin. Its output transistor will turn on. That means it will allow current in this path. This pull-up resistor depends on the output current. How much current we need. This is output point. This time I connected LED in series to this resistor. That means when transistor is on, LED will glow. Otherwise, if we will measure voltage, when transistor is off, we will receive voltage from this pull-up resistor because transistor is off. If you see configuration, I connected positive 12 volt to pin number 3, return to pin number 12. I created voltage divider networks. 4 channel, I created 4 networks. 10 kilo ohm resistor with 1 kilo ohm resistor. It is providing 1.1 volt reference to pin number 6. That is inverting input. The second configuration 10K and 2.2K, it will provide 2 volt at pin number 4. Similarly, inverting input. 10 kilo ohm resistor and 3.3 kilo ohm resistor, and it is providing 3 volt reference to pin number 8. Fourth combination 10K and 4.7K, 4 volt at pin number 10. I used 10 kilo ohm potentiometer, slider arm connected to pin number 11, 9, 5, 7. All non-inverting inputs are connected together. When pin number 7 is less than pin number 6, LED is on. Pin 7 is higher than pin number 6, LED will off because its output transistor will turn off. So that potential here will available here. This time to make it visible, I used LEDs. Now if we compare voltage, pin number 6, 1.1 volt. That is inverting input. Pin number 7 is 2.8 volt. That means this pin is higher than this pin. Output LED is off because when this pin is high, this pin is low, output transistor is turned off. When voltage are less than 1.1 volt, the output LED is turned on because output transistor is active now. It is providing 2 volt drop across its output transistor. If I will increase the voltage level, we can see we have 11 volt. That means when non-inverting pin is higher than inverting input, the output is high due to this pull-up resistor. All 4 channels are working exactly the same. Now we will compare pin number 4 and 5. Here is pin number 4. Sorry, I mentioned here 2 volt. It is 2.2 volt. Pin number 5. When 1.3 volt, the output LED is on. That means this channel is now active. When we will obtain above than 2.2 volt, pin number 2 is providing 11 volt. So this is function of comparator, that when non-inverting pin is higher than inverting input, the pull-up resistor will provide high output due to its open collector transistor turn-off condition. You can take screenshot for this diagram. This is working principle of LM339 Voltage Comparator. If you think this video is informative, give a thumb up. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.